So welcome. This is Integrated Math 2, Lesson 421. We're going to be factoring with area models. So as you recall in 411, we realized we learned what factoring was. That was to break apart a sum into a product. So given a sum that we already have, and then taking it and breaking it into a pattern. So mathematics is also often described as a study of patterns, so it's not surprising that many area models have many patterns. We saw one important pattern in lesson 411, Casey's pattern. That's the last problem we talked about in class. Today we will continue to use patterns while we develop this method to factor trinomial expressions. We're going to try to figure out a way to do it fast. Now, factoring is my very, very favorite part of mathematics. I like to do it. I'm very good at it. I enjoy it. I find it to be extremely fun. And so but I'm looking forward to the way this is being introduced in this book. I think it's amazing. So anyway, we're on 4.1.12. Examine the area model shown at the right and review what we learned so writing as a sum of the product. So I'm going to start with the sum. I've got 10x squared and then negative 35x and negative 4x make negative 39x. And then I'm going to move on to this last one, plus 14. So there's my sum. And then there's my product. Let's find my product. So the way I like to do it with the area model is I like to think about factoring and just greatest common factoring. So what do these two have in common? And they both are divisible by 7. What do these two have in common? Well, they both have x, and they're both divisible by 2. Okay. Then what do these have in common? Well, they both have x, and they're both divisible by 5. Now, right now, once I have something on both sides, I like to double check. 7 times 5 is 35. So the 35x makes sense, but this is negative, and that is not. So that's a little bit tricky. That's why we don't put a negative sign with 7. They don't have a negative in common. However, we need to be sure that when we multiply back up, that makes negative 35. So this does need to be negative 7. And then I look at this, and I go, okay, what do they have in common? Well, they're both even, so that's 2. And, oh, also 2x times 5x is 10x. That's why I didn't change the 5. 2x times 5x is 10x squared. That's why I did not change 5, because this one already worked. That's why I changed the 7 to a negative, to make this negative 35. So then when I look here, negative 7 times 2 is not 14. It's negative 14. And 2 times 2, 2x times 2 is not negative 4. So I need this to be positive 14, and I need this to be negative. So I'm going to make both this a negative number. Negative 2 times negative 7 is positive 14. Negative 2 times 2x is negative 4x, so that works. So then my factors are 2x minus 7, and the other factor is 5. Let me actually use a different color for this, just because it's going to run into it. And so we will have 2x minus 7, and then 5x minus 2. And so those are my factors. Now, let's take a look at what we saw with Casey's. So with Casey's pattern, we saw that if you look at something with the diagonals and what was happening with them. So what I see, what do I see? What's going on? Kind of thinking here. Let me think for a minute. So as I was playing with Casey's pattern, which is, I paused the video and took some minutes to play with Casey's pattern, because since we haven't actually had class yet, I didn't get a chance to think about it. And so when I think about her pattern, and I think if I add these two numbers together, I get negative 39. And if I multiply those two numbers, I get 140. Now that seems counterproductive, because now it's all messy. But if I just take these two numbers, 35 and 4, keeping the signs on both of them, these two add to make negative 39 and multiply to make 40. So I times this diagonal, my two timesing numbers, those are both timesing numbers, right? Let's stay in my results, right? So if we think about multiplying these out, we get the timesing numbers. That number was timesed, and that number was timesed. And so I times them together, and I added these two together because they were like terms. And then if I look at that, it's amazing, negative 35 times negative 4 is 140. And negative 39 plus negative 4 is 39. So this is, if I take these two numbers and multiply them together, I get the top of my diamond. And if I take these numbers and add them together, I get the bottom of my diamond. And so I think, I don't know what Casey's pattern was, and this is what I would come up with in class. So I think that it does hold because of all the things I just said. So I stated the pattern that I'm noticing is that I multiply, I add diagonals with like terms. Multiply the diagonal without like terms. Okay, so I multiply the two numbers on the diagonal without like terms. I add the two numbers on the diagonal with like terms. I multiply the diagonals without like terms. And then if I look at the coefficients of my added diagonal, they are the two numbers that multiply and make those. So that's what I'm seeing. It's just pretty dang cool, actually. Okay, so let's see. Let's continue. So that's what I meant to do. Okay. So when we factor using tiles, we need to determine how to arrange the tiles to form a rectangle. Using an area model to factor requires a slightly different process. Okay, so what we're talking about here is a polynomial in the form of ax squared plus bx plus c when a is not 0. So a, b, and c are just numbers. And a cannot be 0 because if a is 0, this x squared term goes away. And we're left with a linear term, linear product, linear sum. It's called a quadratic expression in standard form. To develop a method for factoring quadratic expressions without using algebra tiles, we're just going to model how to factor with algebra tiles and look for connections within an area model. Okay, Miguel wants to use an area model to factor this. He knows that 3x squared and 8 go on the rectangle on one of the diagonals. It doesn't matter which one. I like to put them this way. Your textbook's going to be putting them this way, so I guess I'll just adjust. I like them that way. That's the way I would do it. So, and so we need to figure out how to split the 10x and explain why it makes sense. So how do we split 10x? So how are we going to split 10x? So we've got this. We need to split 10x. Finish the rectangle by deciding how to split and place the remaining term. We need to split 10x into two pieces. Now there's lots of ways to split 10x. I can split it as 1 and 9, or 2 and 8, or 3 and 7, or all sorts of choices. But there's too many because I can also use positive 21 and negative 11 to make 10x. So, I mean, basically, you can't give me a number that I can't add to, find another to add to it to get 10x. So I need to be really careful here. So I'm going to go ahead and try the diamond a little bit to see if it'll help me. And so I know that I had to multiply this diagonal to get the numerator, right? To get the top. So 3 times 8 is, what's 3 times 8? 24. So I have to multiply those together. So I multiply, just so we know, I times 3 times 8 because that's what I noticed up here. Okay, so that's why I did it. And then 10 is just my bottom number because my sum, so if we look back here, 39, bottom number. So that's what I'm thinking. Okay, And so then I'm going to just do my diamond thinking, which we've gotten really good at. We've been doing diamond problems practically since the second week of class, first week of class. So, somewhere in there, right at the beginning, we started diamond problems almost immediately. Numbers that multiply to make 10, but add to make 24. And I think they are 4 and 6. And that is not the greatest color. Let me try this green and see if it's any better. Yeah, that's good. And so I think this is 4x and 6x. Because 4 times 6 is 24. And 4 plus 6 is 10. So I definitely think I'm going to split 10x as 4x and 6x because 4 times 6 is 24. And 4 plus 6 is 10. Now I'm going to write my area as a product. So I'm looking at my box now. So what do these two have in common? They both are divisible by 4. These two are both divisible by 3 and x. These two are only divisible by x. These two are divisible by 2. So 3x times x is 3x squared. 4 times x is 4x. 4 times 2 is 8. 3x times 2 is 6x. So that seems to have worked out really nicely. My product then is 3x plus 4 and x plus 2. Now, I'm going to check to see if I'm right. It doesn't tell me to do that, but I'm going to do it. I want to be sure I'm right. So to check if I am right, it's really very easy. I'm just going to multiply, right? Which we are good at, most of us, without a box. So 3x times x is 3x squared. 3x times 2 is 6x. 4 times x, is 4x. And 4 times 2 is 8. So I get 3x squared plus 10x plus 8. Okay, which is what I started with. Right? Those match. So that's good. So it looks like it checked. So this is me checking to see if I'm right. Okay. Kelly wants to determine a method for factoring this. She remembers Casey's pattern for diagonals. She has his 2x and 6x into the rectangle as shown. Without actually factoring, what do I know about the two missing numbers? Give me a second. Okay, so I'm going to be putting this down here in just a minute in case you're curious. So Kelly wants to determine the method. What do I know about the two missing numbers? So the two missing numbers have to add up to 7. And multiply to make 12. And 12 I found because that's 2 times 6. Okay, that's what I know. To complete Kelly's area model, create and solve a diamond problem using the information we just got. So that should really be B, but okay. So must add up to 7. And multiply to make 12. My two numbers are 3 and 4. How does the diamond problem reflect what I know about the 7x term and any patterns from the box? So 3x plus 4x equals 7x. 3 plus 4 is 7, that's good. 3 times 4 is 12. Okay, and then 3x are the 3x and 4x are my question marks. Okay, use your results from the diamond problem to complete an area model. Okay, so I'm going to draw the area model again. I already have placed in my area model. I'll place them in black, 2x squared and 6. My new placement, my two green numbers, will be 3x and 4x. And then I'm going to try to write the area as a product of factors. So 3, 2x, and I don't have room to write underneath, so I'm going to write above, x, and 2. So 3 times x is 3x, 3 times 2 is 6, 2x times x is 2x squared, 2x times 2 is 4x. So it works out. By the way, I'm checking as I go. So area is a product of factors. Use the diamond problem to show why the area model for Miguel's problem works in part A. We already did. So we don't need to do it again. Using algebra tiles, factor. Use the diamond in the box, then write the area as a product. So I'm going to go ahead and try on my own. You're going to try on your own to do this. So go ahead, pause the video, and do your best to try to get this done. Just going to interrupt for a minute. So you'll notice where I've placed everything. So 2x squared, 3 goes here, and the 5 goes here. I need to put the x on it because we don't really have x's in our diamonds. So I didn't put the x on it. I could have. I didn't. But that's where everything went. Okay, keep going. Okay, so what you can see is that I have found my two numbers. So 6 came from 2 times 3. Then I figured 2 times 3 makes 6 and adds to make 5. That's right. Add, multiply, and add. So then 2 and 3 go in my diamond, my box right there. Again, the blue numbers were already there from right here. Then I look at what they have in common, and there's my factor as a product. All right, hope you did okay. Let's move on. Rather than continuing to tuck that under, I'm going to go ahead and bring this to the front. So factoring with an area model is especially convenient when algebra tiles are not available, or when the number of tiles necessary tiles becomes way too large to manage. So use the process that we just used to try to factor this. Okay, so we're going to build an area model. We're also going to build a diamond. What do I know from the problem? So I know this is 17 from the problem. I know from the problem that 6x squared goes here and 12 goes there on one of the diagonals. I'm being consistent, always putting it on the same diagonal, but you can put it on the other diagonal too, as long as it's one of the diagonals. Okay, so that's what I get from the problem. So then I need to think. And so I do 6 times 12. 6 times 12 is 60 plus 12, which is 72. So my timesing number is 72 and my adding number is 17. So go ahead and pause the video and come up with just your two sides of your diamond. The diamond problem helps avoid guessing and checking. So that's the whole point of the diamond. But anyway, figure out what your two numbers are. So I chose 9 and 8. So what I do when I'm thinking about this to help me choose, 9 plus 8 is 17, 9 times 8 is 72, but there's a lot of choices. So I kind of just, if I have no idea, okay, I start at the beginning. 1 times 72, which is way too big. 2 times 36. 3 times 12. 4. Yep, 4 times 4 goes into 7 twice. Okay, so 23. No, is it correct? I know it goes in, but now I can't remember how many times. So I'll use a calculator. 72 divided by 4, 18. 5 does not go into 72, so I skip 5. 6, I know it's 6 times 12. 7 does not go into 72, so I skip 7. 8 goes into 72 9 times. And now I'm back because there's 9. And so I don't need to keep writing because 9 is my next number. So these are the only numbers that multiply to make 72. But if I'm stuck, I make myself a list like this. 72 is kind of crummy list because it's still pretty long. But it's still better than thinking about numbers that add to make 17. There's just too many. Way too many. So this helps me avoid guessing. So anyway, my numbers are 9 and 8. What do I do with these two numbers? Well, that tells me how to break apart 17x. 17 is 9x plus 8x. So I'm breaking that apart. And so 9x and 8x go here. So go ahead and pause the video again and try to find my edges. Okay, good luck. All right, so I didn't find the edges, but that's okay. So I'm going to get 3 and 2 and 3. That's supposed to be x, that's supposed to be x. And 4, 3 times 4 is 12. So my product is 2x plus 3 and 3x plus 4. And go ahead and just try these. And this one is in the wrong place, but go ahead and try those and see how you do. Okay? And I will have answers in just a moment. Okay, so these are my two answers. I did not show my work. I did it all here. Eventually, you will get to a place with factoring where you do not need to show your work. I don't expect, you bet you should have work for these. I didn't put it down. I don't have time to put it down now. But there I am, x plus 3, x plus 6, 4x minus 3, and 4x plus 5. On this one, I almost had this. And then I noticed that that was negative. If that had been a positive, that would have been correct. So if you had that, that's what happened to you. Okay? All right, we'll talk soon. See you guys soon. Have a great day.